Welcome to the channel. We are looking at some likely questions on JAMB, and we are looking at the vector. And looking at the vector, we are considering an example on one of the examples of vector. One of the examples of vector is force. Then the question is, what is even vector? Vector is a quantity that has both direction and magnitude. So a force has direction, force has magnitude as well, which means force is a vector. Now look at this question. Two forces 8 Newton and 15 Newton acting along the vertical and horizontal axis respectively act on a body of mass 3 kg. What is the acceleration of the body? What is the acceleration of the body? Let's look at it. Let's solve the problem. The first one is looking at this problem. You can solve it this way because it's on two axes. We have our y-axis and we have our x-axis. So on my y-axis, I have 8. My y-axis is 8. And my x-axis is 15. My x-axis is 15. 8 Newton, 15 Newton. Actually, this one, I join this line together, is called the resultant. And that is exactly what we are going to do. But we are not going to join the line together. We are going to solve it mathematically. Now, I call this one my 8. My 8 is my V1 and 15 is my V2. In other words, we have V1 equals to 15 Newton, V2 equals to, V1 is equals to 8 Newton and V2 equals to 15 Newton from here. So if this is correct, then we have R, which is the resultant, equals to square root of V1 squared plus V2 squared. V1 squared plus V2 squared. From here, my V1 is 8 and my V2 is 15. So I have the square root of 8 squared, which is my V1, 8 squared plus 15 squared. 8 squared plus 15 squared. Now, what is 8 squared? 8 squared is what? 64. So we have 8 times 8, that is 64. We have 64. 2, 2, 5. Now, adding the two of them together, which means my R, which is the resultant, is we have 9, 8, 2. 200, the square root of 289. And the square root of 289 will give me, the square root of 289 will give me 289. Gives me 17. This will give me 17. So which means that my R is equal to 17 Newton. This is not where we are going because the question is asking us what is the acceleration of the body. We have only succeeded in getting the resultant of the body. So we want to look at the acceleration of the body. Let's look at the resultant. So we have, but remember, F is equal to R. The force, this is the force. Remember, this is the force. So if that is the case, you remember in physics, we have a formula which says F is equal to ma. What does that simply mean? That means F, force, is equal to mass times acceleration. Is equal to force, mass times acceleration. That is F. So if that is correct, then we have my F. Remember, I said that F is equal to R, and my R is equal to 17. So which means F is equal to 17. If this is correct, then we have F is equal to ma. What is my mass here? My mass is 3 kg, which means M is equal to 3 kg. If M is 3 kg and my F is 17, then I have 17 is equal to 3 times A. I don't know my acceleration, and that is exactly what we are looking for. That is what the question says we should do. This gives me 17 is equal to 3A, where A is the acceleration. Then what we do? We make A the subject of the formula. At this point, make A the subject of formula. How do you do that? You do that simply by dividing 2 by 3. So you have 3A over 3 is equal to 17 all over 3. This 3, you cancel this 3, then which implies that A is equal to 17 over 3. And what is 17 over 3? That simply means you divide 17 by 3. You divide 17 by 3, and when you divide 17 by 3, it gives you 5.17 divided by 3 gives you 5.66666. Gives you 5.6666. Yes, this one we need to do something. This one is continuous decimal. Are you not going to leave it like this? If you have this one as in an exam, they will always give you will always see something like this: 5.6666, maybe 5.6, 5.67, and so on. Then we are talking of the force. Force has 2 decimal points. So at this point, you simply say this is 5.7. You can easily say this is 5.7 into 1 decimal point. But the maximum you can give it to is 2 decimal points, which now if you do that, that will give you 5.67. Look at the options, but in this case, because we are dealing with this force, we are having our answer as 5.7. We can have our answer as 5.7. Now, if I put it like this, 5.7, what does that mean? This one does not represent the answer. Why? Because you don't know 5.7 what. Is it 5.7 kg? Is it 5.7 gram? Is it 5.7 liter? You don't know. So it is important that you don't omit the SI unit. And what's supposed to be the SI unit? What is the SI unit of the acceleration? Because we are dealing with acceleration. It is acceleration that we are looking at. What is the SI unit of the acceleration? You are looking for the acceleration. No, the SI unit is what? Meters per second square. Meters per second square. Remember, if you are given this, you can have option A to be 5.7 kg. Option B to be, I can give you option B as 5.7 Newton. And option C as 5.7 meter per second. Option D as 5.7 meters per second square. It is you at this point to know which one is the correct one. This one is talking of mass. You are not looking for mass. You are looking for acceleration. This one is talking of force. You are not looking for force. The question does not ask you to look for the force. So this one is wrong. This one is wrong. This one is talking of velocity. You are not asking, the question is not asking of velocity, so this one is also wrong. The question is asking is telling you to find out the acceleration of the body, and this is the SI unit for acceleration. So this D becomes the correct answer. So if you are benefited from this video, you can share it with your friends and even subscribe. Look, this one you have on the board is your practice question. This is the practice question. Two forces 16 Newton and 25 Newton acting respectively act on a body of mass 5 kg. What is the acceleration of the body? So This is your practice question. Solve it and drop your answer at the comment section. If you have benefited from this, you can also share it with your friends and let them look at it and share it with other friends as well.